Welcome everyone, thank you for coming by. This is Seamless GIS Modernization Insights from OWASA's Utility Network Implementation. So we'll kick things off now. Just a quick agenda about what we'll talk about today. So we'll go through some introductions and background. We'll get into the first of the two projects that we'll talk about today with OWASA. The first is that utility network planning project, and then the actual implementation of the utility network. At the end, we'll go through some lessons learned and actionable items.
Thank you. I'm Beth Canada. I'm the GIS coordinator at OWASA, which is Orange Water and Sewer Authority. We're located in southeastern Orange County. And we serve the communities of Carrboro and Chapel Hill, including University of North Carolina, which is our biggest customer. Almost 40% of our water sales are for the university purposes. We serve a little over 86,000 residents and about almost 2,300 meters. In terms of size, we have almost 335 miles of sewer, about 385 miles of water, and a small reclaim system that takes water from the treatment plant back to the university's heating and cooling system. Hit the space bar.
Yes.
And so this is about our process of going to the UN. We actually go live in the UN in 2 weeks. So this is a timely conversation or presentation. This all started when I went to an ESRI conference, I think it was in 2019, where I went to a presentation where they said ArcMap goes away in 2024, and you can't edit your geometric network data in ArcGIS Pro. So that was a kind of a wake-up call for me. And during COVID hit, had a lot of time to research about the UN. Just through ESRI's documentation, some presentations. Also reached out to other utilities in our area to see what they were doing. Nobody had a full migration that I talked to that were close in our area, but they had already started the process and were ahead of me. And I quickly came to the conclusion that it's kind of complex in terms of the data structure, all the topology, the network rules, the attribute rules. And we also have integrations with other systems. We use CityWorks, which is our work order management system. Our customer service database was integrated with our GIS, our CCTV, valve inspections, all of this. And so I quickly realized that we would need help. I don't think this is something we could do on our own. So in 2022, we went out with the RFP and then chose Timmons Group to help us with the implementation. At the time, they seemed to have the most experience. We also wanted to get somebody that was business partners with both Trimble, which is CityWorks, and ESRI. And they also came highly recommended. And I also can vouch for it myself. They were very organized. Their planning has been really good. They're also very flexible. If something comes up and we're having problems with something, they've been able to adjust the schedule. And they're also, communication has been excellent. They get back very quickly, and they're very technically inclined, very good. Anytime we've had some technical issues, they've been really helpful and quickly resolved and come up with solutions. So we've been very happy with them. And then I'll turn it back over to Drew, but we did do this in two phases is what we call it to him. That's what he was just mentioning a minute ago. Phase one, and we divided it up over several fiscal years, which made it a little bit more affordable. Phase one was basically getting our architecture. We had just a single machine deployment with just ArcGIS server and CityWorks all on one server, and they set us up with multiple servers. And then also came up with a strategic plan on what we would do exactly, and also sort of a data cleanup effort with phase one. And then phase two is the actual migration to the UN, and we go live with it in a couple weeks, as I said before. So Drew will speak more in depth about what those steps are. Thanks.
Great. Thank you, Beth. That was smart researching a utility network during COVID. I probably should have done that instead of watching so much Tiger King. That probably would have helped me out a little bit more. So my name is Drew Perzicki. I'm a senior technical analyst with Timmons Group. I've been there for 2.5 years now, working in the geospatial utilities team. I am subbing in today for Allie Kennedy, who is our group leader for geospatial utilities. So you can see some facts about Timmons Group here. The thing I want to highlight is that we have over 200 IT and GIS consultants in our company. We have been Esri business partners since 1995, and a few of us, myself included, have our FME certified professionals and the UN specialty certification. All right, so we'll dive into the projects now. So the first one is that utility network planning project. So the goal for this one was to document all of the GIS configurations, all those integrations that Beth mentioned, and the needs that we needed to plan for the actual implementation. So the solution for this was to conduct on-site discovery sessions. And these were used to determine stakeholders' GIS use, needs, and pain points. So how are they using GIS, right? So whether they're editing, viewing, using it in mobile, however that GIS data is being used, we want to document that. The needs, so what do they need to get out of this project, right? So what do we need to keep in place, keep functioning throughout the implementation? And finally, pain points. What can we improve upon during this implementation? So any workflows, any edits, any capabilities that users are having difficulty with, what can we make sure we can improve upon once we're in the utility network during this whole project? So the outcomes of this were a data readiness assessment. So looking at OWASA's data quality, what needs to be cleaned up prior to moving to the utility network. We came up with a utility network plan that was documenting that current state configuration, and then we came up with some future state recommendations based on the current state documentation and their needs for the utility network. And after that, we came up with a budget and a schedule for the actual UN implementation. So for that project, the goal was to migrate out of ArcMap and into GIS Pro and the utility network. So again, we wanted to make sure that we had continued functionality of all their integrations. Whatever that data was touching, we wanted to make sure that their users didn't lose any of that functionality that they currently had in all of their capabilities. So we'll take a look at the workflow in the next slide. But the outcomes of this particular project, 3 utility networks. So that's that water, reclaimed water, and sewer. We reconfigured CityWorks. We updated Python scripts, so everything that went into those automations, we made sure it worked correctly with the utility network as well. And then we upgraded ArcGIS Enterprise from 10.9.1 to 11.1. All right, so I'm going to go through each part of the workflow. I know it's a lot, it seems like a lot, but hopefully, is anyone currently planning or in the process of thinking of moving to the utility network in the near future? All right, a few? Awesome. Well, this might look like a lot, but hopefully, going through this, you can see how important each part of this process is, how everything kind of builds off each other. So while it may seem a little daunting moving to the UN, it's not as scary as it can be made out to be. So again, going back to those discovery sessions after kickoff, and we talk about all those GIS use needs and any pain points, and we also conduct a data model review. So we went through OWASA's data with them, and they identified any fields or particular feature classes that they might not need anymore, right? So why bother migrating something that we're not even using? So after that discovery phase, we went into that data readiness assessment phase. So that's why I talked about earlier, looking at the quality of that data, making sure we can identify any inconsistencies, any inaccuracies, any possible errors that will come up in the future, so that OWASA can get a head start on actually cleaning up that data before moving into the utility network. It's now coming into that data model phase. So after all of that discussion during the discovery, data model review and that data reviewer checks that we conducted, we're now moving into actually identifying how everything is going to be migrating out of OWASA's utilities now and then into the utility network. So we first come up with a data model matrix, and we show how all of their source feature classes are going to be migrating to the UN schema. So if you're not familiar with the utility network data model, it's kind of made up of 3 parts, right? So we have the overall feature classes, which if you have a lot of feature classes now, they're going to be condensed into 5 or 6. So it might look a little different in that way. Feature classes are then broken down into asset groups, which are the subtypes of those feature classes. So you have the feature class, the asset group, and then one tier below that, you have the asset type. So in this data model matrix, we're showing how each feature class is going to be migrating into which feature class, which asset group, and then which asset type in the utility network data model. So this is all broken down in a spreadsheet by feature class, and then we do the same thing for fields. So we look at how fields are going to be migrating as well, whether those fields are going to be renamed, keeping the same name, maybe the values are going to be changing, any domains that are going to be changing. We want to identify, okay, it's going from this text-based value to this, integer, right? So we document all of these changes to make sure that we're aware of how everything is going to look in the utility network. So after we develop this migration internally, we hand this all to OWASA and say, how does this look? Does this make sense to you? Is there anything we want to change or, review? So this first iterative process of going back and forth with feedback, making sure that everyone's on the same page and everyone's happy with how things are going to migrate. So after the approval of that spreadsheet of how all those feature classes and fields and values are going to migrate, we move into the actual data modeling phase. So we take a file geodatabase, which is called an asset package. This contains all of the configurations for the utility network. So all of the feature classes, fields, domains, particular properties of the UN are stored in this asset package. But we first develop just that core base of this is what your fields are going to look like. This is all your domains that we're adding or things that we're renaming. So how does this look in a file geodatabase without any data in it, right? So we're just looking at the base data model. So we develop that from the migration matrix, and we, again, get approval or look for feedback on that data model. Once everything looks good in that file geodatabase, then we can move on to the actual data migration phase. So we use FME at Timmons Group. Any users of FME here? Awesome, couple. Love FME, highly recommend using it. It's great for this process of transforming, adding, taking away data, doing whatever you need to do to migrate data into the utility network. So we take OWASA's starting data, right, the data that they've been using, all their feature classes, and we use FME, create a workbench that takes all of their data and migrates it to the UN format. So now we're populating that file geodatabase with all of that data that's going to look new, right? It's going to look like the UN schema. It's going to have all those changes applied to it that we first developed in that migration matrix right here. So now that we have that populated asset package, that file geodatabase, again, we hand that over to OWASA and make sure that we're all on the same page, that everything looks like it migrated correctly. Are all the fields that you're expecting to see, are they there? Are all the values migrating correctly? Do we have any outstanding or outlying domain values that don't match? Right? Are you missing any data? Are there features missing? Are there extra features? So we make sure that everything looks good as far as the migrated data to that file geodatabase. Once everything looks good there, we move on to deploying the actual utility network from that asset package locally on our machines. And that's when we begin the internal testing of making sure everything looks good as far as functionality, making sure that things match that migration matrix, and everything's working as intended in the utility network. So after that, we then move on to actually deploying in the test environment for OWASA. So again, we take that migrated data in that file geodatabase, that asset package, and bring it over to OWASA's dev and enterprise site. So we deploy that entire utility network with all of that new data. Then we begin to test integrations as well. So Beth mentioned, everything that this data is going to be touching, and that we need to, make sure that we're reconfiguring everything that's going to be using these new UNs. So after we make sure that all the integrations look correct, that everything's working as intended, then we start the training process. This is when we really introduce the utility network to the whole organization and really show what this is going to look like when they begin using it full time. So for a lot of folks, this is an introduction to the utility network, right? So the first time they're seeing things, whether they're field editors, office editors, just people viewing it, right? So we start at a very high level of just an introduction to the utility network data model, and we go all the way down to advanced workflows, whether that's editing the utility network itself or editing in ArcGIS Pro. So we go through all this, and then we provide OWASA with a series of steps of things we want them to make sure work. So all these tests, they go through each utility network, making sure that They go down the list, checking off that everything works correctly. If not, we go back, identify what caused that issue, and make that change so that they can still continue to test where that first issue was, and then test what's actually working correctly. So after the training and testing phase, then we can finally move to the production deployment, which Beth mentioned is happening in just a couple of weeks. So kind of the same process, except this time there'll be an editing freeze, right? So they stop editing, they hand us all of the data. Again, we use that FME workbench to migrate all of their data to that utility network data model. Then we deploy it to production. Again, making sure that everything on our end that we're seeing is functional, right? Everything in the utility network, everything we set up in Pro, integrations are working correctly. OWASA makes sure that everything they're seeing works correctly. And then once that's done, you're in the utility network. Very easy. A couple highlights I want to talk about first is the data model design. So I talked about that data model matrix at the very beginning, right? So this is a really important step because this is the foundation of what you're going to be using, you and your organization. So OWASA was very diligent in the beginning in laying out their migration, how it's going to look, and getting any feedback back to us to make sure that we had everything correct in this matrix, because this matrix is going to be a reference for the rest of the project. So it's important that you get this accurate and correct the first time rather than having to go back and continue to make changes. So again, it is an iterative process. You're going to go back and forth, making sure that everything looks good, but it is a very important step. So the outcome of this is that data model customization I talked about, right? So it's fitting this UN solution that, you get some base fields, domains, attribute rules, things like that, but then you can further customize that to fit your organization's needs. So OWASA included a bunch of fields and domains and things that their users and organization needed to maintain in the utility network. So you can see a sample of this migration matrix here. This is their reclaimed water. So an example I like looking at here is this reclaimed water line. So this is their source feature class. That's their reclaimed water line. It contains all of their reclaimed water lines. And so in the utility network, we go over to that second half on the right. And we can see that is migrating to the reclaim line feature class in the utility network. Then it's going to be under the reclaim main asset group. Remember, that's the subtype of that feature class. So that asset group will be reclaim main. And then depending on the value in their operational class field, that will determine the value for their asset type. So it's either going to be a transmission main or distribution main based on the value of that field. And so that's just a kind of small sample of how you may migrate your data, taking different values in certain fields to determine the feature class, asset group, and asset type. So we also have data dictionaries. So this is using the Generate Schema Report tool in Pro. It's a great tool. It outputs everything within that database from those fields, domains, attribute rules, anything that's contained within that database and the UN is going to be output to either an Excel file, I think HTML, PDF, and is a great reference for users that don't actually have access or just don't want to go through perusing the database. So you have this PDF as a reference that you can provide or easily look through. Then we kind of have a UML-ish flow chart here on the right side. So this is just a further visual of how the feature classes break down in the utility network, starting with that reclaim line at the top, and that purple line splits off into the different asset groups. And then the two asset groups in the middle there split off into all of those, to the orange lines, which are the asset types underneath those. All right, another project highlight, editing tools. So anyone in Pro right now using attribute rules, contingent values, editing templates? Yeah, these are great to have and things that we definitely want to make sure are set up during this implementation. So the goal of these editing tools is to reduce your clicks and improve your QA/QC workflows. By doing so, you make work more efficient for yourself as an organization and for individuals as well. So we'll start with some attribute rules. So with attribute rules, you have immediate calculation and validation checks. So those immediate calculation rules, a couple examples of those that we set up are generating IDs. So whenever a new feature is created, a unique ID is automatically generated for that feature. Another one is diameter from intersection. So if you place a valve on a main, that valve automatically gets that diameter value from that main without having to manually enter it. And that's also making sure that no one's missing that diameter value, which you're talking about. So it makes it a lot easier for folks not to have to remember to look at the diameter. They just know it's going to be automatically populated. And finally, split line at new asset. Again, so if you're placing a valve on a main, and whenever this particular valve is placed, it needs to split that line, we can do that as well. Validation rules. So this is the ArcGIS Pro version of Data Reviewer. So this is a great way of improving those QA/QC workflows, kind of doing self-QA while you're editing. You can run these checks, making sure that you're not missing anything and that everything is going to be correct when you eventually post to the default version. So a great example of this is finding invalid domain values. I love this one the most because it points out exactly where values within a field are not a part of that domain that's applied to it. Finding orphan features, if something's just floating out in the middle of nowhere or not connected to the rest of your network, you're not really going to be able to find out unless you run something like this that's going to point out that exact feature. And finally, finding cutbacks. It's a great way to find where someone accidentally put an extra vertex in a line, or you have an acute angle that for some reason goes backwards and then continues on. Contingent values. Again, so this is great to making sure users are not inputting incorrect data. Contingent values link values between multiple fields together, so when you choose one value, only a select number of values come up for the other field. So for instance here, material and diameter were used. So when a material like PVC, for instance, is chosen, only the allowed diameters for PVC come up when a user clicks that dropdown. And vice versa, if someone chooses a 4-inch diameter, only the allowed materials for that diameter will appear when they go to choose that. And you can still override that, but it makes it just a little bit more difficult to input bad data. And finally, group editing templates. So we have a few for each of water, sewer, and reclaims. We have a GIF over here of I think that's the water one. So group editing templates are great for repetitive workflows. So for instance, this one is creating a tap fitting on a main, followed by a service valve and a hydrant, all connected by a hydrant service line with just a few clicks. And you can save specific attributes within those templates so that every time you're creating these features, all those attributes that stay the same each time are automatically populated. Same thing for sewer. We create manholes that are automatically connected by gravity mains, and then reclaim, kind of a similar thing for water, creating a cap, gate valve, and blow-off connected by a service line. All right, so Beth mentioned that we upgraded their enterprise from 10.9.1 to 11.1. So this was just to ensure long-term support for the UN and that continued functionality of everything that UN is going to be touching. Along with that, we rewrote Python scripts, making sure that everything's in Python 3, making sure that we're using ArcGIS API for Python. So this is required for editing branch versioned feature services, which is what the utility network uses. All right, so we're no longer editing against a database directly. We're publishing feature services from that database, and then users are editing against that service. And then we made sure to rewrite the scripts to make sure we're pointing at the UN feature services themselves. We also created combined meter SQL views via stored procedures, which is a great way to view all of their meters across each utility in one place. All right, CityWorks reconfiguration. So this is a bit of a big one, right? So we wanted to remap their feature services to use the new ones, right? So we're making sure that, again, pointing at the utility network data. We applied definition queried feature services here that we published to make sure that everything looks similar to, prior to the utility network. All their users still see essentially the same layers, right? The same names, using those definition queries to make sure they're seeing the data that they're used to seeing in those layers. Again, we have those materialized views for aggregation of the meters across the 3 utility networks. We have reports, and then we rebuilt those relationship classes in CityWorks. We confirmed that the work history was brought over during the implementation. So we kept those unique IDs to make sure that the work order history was not lost during the migration and the implementation, and thereby making sure that those CityWorks functions were maintained throughout the whole process. We made sure that inspections were adjusted for asset updates to match those new coded values. So remember, going back again to the migration matrix, some of those values in those fields are going to be changing. And then updating the editing from the SOE to use a headless portal user. All right, so diving into some critical steps here. So the first one, ensure that features, domain values, and the fields that are being removed are all tracked during the migration matrix phase. So again, this is one that you're going to be referencing throughout the implementation project. This migration matrix that's capturing everything, all the changes that are being made. You also want to record features or fields that are being removed. So that way when you get to that migrated data, that new UN data model, you're wondering, why is this field not here? Or why are these features not here? Well, now we have a record of, well, that's right, we decided to remove them for this purpose or at this point. Right? So we want to make sure that we're capturing everything, every change, even if those changes are just simply deleting something. Within that FME migration, we want to set up a process to abandon feature Z values to a negative 9,999. This is because the UN recognizes Z values, those elevation values, when it analyzes connectivity. So by setting the value to that for the abandoned features, we automatically take them out of connectivity, right? So when you're looking at that in Pro on a 2D map, it's not going to look any different, right? That abandoned main is still going to be there. But the UN sees it way down here, and it's not going to return that value when you're running a trace or looking at subnetwork attributes. We also designed a process to determine feature counts before and after migration. Right, so we count the number of features within each of OWASA's source feature classes, and then after the migration into that UN data model, we still have that record of the number of features that migrated into each feature class, each asset group. And this is so, again, we can go back and kind of QA ourselves and say, okay, we have the same amount of features that we started with, that's great. Or we're missing features, right? Or we have more features than we started with. Was that intended? Sometimes. If not, then we can go back and analyze that issue, find out where that problem was occurring, and then make that change. We can also clean up errors in the utility network on a local, on our local machine after migration for things that can't necessarily be taken care of in FME itself. So this makes it a lot easier when you're cleaning up errors on your machine versus after you're deploying it to an enterprise environment. So you go through all the work of setting up all those feature services and making all the configuration set, and then you begin editing and setting or cleaning up that data. Just do it locally, save yourself the hassle and the time of doing it now on your machine, make it a lot easier. And finally, saving a backup of the staged UN before running apply asset package. So when you're deploying utility network, it comes in 2 parts, right? So we stage the utility network in an enterprise database, and then we apply the asset package, which means then we actually give it the data. So with the stage UN, we provide the framework of the UN in a database, right? But there's no data there, no data model. It's just saying, hey, this is set up for the UN. Then we run that apply asset package, which gives it the actual data. But save a backup of that database with just that framework, just that staged UN. That way, if anything goes wrong during deployment, if you have to restore that backup, you're starting with that framework already, rather than starting from scratch. All right, some lessons learned throughout the course of this project. The first being, begin training early. So start training early, give your users enough time to test, to go through all the updates that we make from feedback from that testing. The more testing that gets done now, the easier your life will be after go live. So make sure you're capturing any issues that are going to come up. Make sure you're familiar with all of your workflows during the test phase rather than finding something out when you've already gone live. Short training sessions at each deliverable. So we found out it really helps when at each phase of the project we're going through with OWASA or with whoever that you're discussing everything in detail. So that way, we're getting the feedback that we're looking for, but OWASA also knows what they need to spend their time on because they have jobs to do outside of this project. That's, my whole job, but they have something else to do other than, stare at a spreadsheet for multiple hours. So finalizing the data model and migration prior to training. So again, making sure that everything looks correct, making sure that everything is reviewed and approved before training. Make sure that you don't have any delays because of updates that need to be made or because something was incorrect, and then we have to kind of start the process over. All right, finally, some actionable items. So you can start your data cleanup now. The better data you have, the better UN experience you'll have. Doesn't mean if you have bad data that you can't go to the utility network. It does help, but you can still clean up those errors in the UN. However, the earlier you start, the better your life will be. All right, so start people working on those updates to your data now versus down the line. You can hit the ground running with Esri's utility network training, so they have a lot of great documentation and instructor-led training out there that you can definitely get your hands on and start earlier. Also a lot of great ArcGIS Pro documentation and training out there as well. Plan ahead for those critical integration items. So whether that's CityWorks, automations, web apps, anything that UN data is going to be touching and being used by it, making sure that you plan for those and test them. And finally, a thorough review of the migrated data post-migration is key. It is very tedious to be looking through every single field, every single value, every domain, everything within that asset package file geodatabase. It's very time consuming, but again, because this workflow, this implementation builds off the previous phase, the work that you put in earlier is going to save yourself a lot of time down the line.
I would just reiterate the time. It's probably been my biggest issue with this is just the amount. It's just me. We don't have, I have a couple of guys that help edit, but it is just me. And so I was unprepared for the amount of time it takes just for the data cleanup effort. And then also after some of these tests database, comparing it to our current data. That's just, but like you said, it's worth the effort because when you end up with a much better product when you go live. But that was just an eye-opener for me. There were so many other initiatives, just your daily job, but also a lot of other regulatory issues that have been happening in utility space, primarily like the lead and copper, also like PFAS and that kind of stuff. And everything kind of hit at the same time. So that was just something that I wasn't prepared for, but it definitely does take time. But I learned a lot.
All right, well, that's all we have. Happy to take any questions.
The estimated cost to do something like this?
It's going to depend on your, utility, your scale, how many utilities you want to do. So it really depends on that. Yeah.
So does that take it, you mentioned something about the UN model being implemented to 5 feature class or something like that. We have more. Does that include going down to the meter level?
Can you repeat the question one more time?
Does the UN model include going down all the way to the actual meter point?
So just to go back, the first question was as far as cost per, for the project. So that's really just going to depend on utility, the amount of data that we're dealing with. Certainly happy to discuss it after this, go into more detail. The second question was, does the utility network data model go down to the meter point? Yes. Yep. And so we can get into as much or as little detail as you need, right? So if your data is pretty generalized, we can keep it that way. But if you have the data and the information to get more detailed, you can certainly do that as well. Oh, yeah.
Any particular reason why you chose 11.1 as the enterprise version to upgrade to?
You want to do that one?
Yeah, it's because, he asked why did we move to Enterprise 11.1, and that's because of you also have to pair that with the UN version. And so we had to pick a version to move to, which I believe are at 6. And so you have to, Esri has documentation on which one you went in right now, that's 11.1. I think after we, at some point, we look at upgrading to the higher version and then upgrading enterprise as well, but you have to be in sync. Yeah.
The group editing templates,
Mhm.
you said, is that part of the utility network model and you guys were tweaking them, or is that all complete customization that you set up for them?
So the question was, I got you. Question was about group editing templates, whether they're in the UN data model. Where is it? It's somewhere. There we go. So whether the group editing templates are in the UN data model or if that's just something we customize. So Esri with the UN Solution Foundation, you get a set of maps and a project. They provide you with symbology and some kind of starter group editing templates. But a lot of times we're customizing this based on the organization's needs. So it's not a UN thing, this is just a pro thing that you can take advantage, without the UN. Yeah, great question though. Yeah, in the back.
So a lot of times we'll receive data from clients and like there'll be floating point features like manholes or something. If you have your utility network set up where like a manhole has to be connected to a gravity main, how would that work when you're importing it into a utility? Would it just disappear, or how would that work when you're importing it?
So the question was, how does it work if you're importing data where a manhole needs to connect to a gravity main?
Yeah, like
So,
if you have a floating point that's not connected to anything from an existing data set.
Is it disconnected device?
do you want to answer?
Um, we certainly have that situation where you have meters that are free floating, and it just wouldn't be, if you do a trace, it just wouldn't connect to it, but it does come in to the data model, if that makes sense.
Oh, yeah.
But it will not be part of, if you wanted to do a trace to get your customers, and we certainly have some what we call free floating meters that we don't, with time, we'll go out and survey them and get them connected to the network, but right now they're not connected. But it doesn't stop you from migrating to the UN.
Yeah, and one aspect of that is, a lot of times folks and organizations are aware that they have floating data or data that's not snapped, and that can be taken care of during FME, in FME during the migration process. So if if that data exists already, we can make sure that, hey, if there's a meter or a manhole within a foot of the end of this main, just make sure it's snapped. So it'll go through the migration, and then in the UN, it'll be connected. Yes.
You mentioned that you had to upgrade Python
Mhm.
scripts to use the ArcGIS API because of branch versioning.
Mhm.
So is that opposed to ArcPy scripts, like to make like a geoprocessing tool to do this kind of stuff?
Correct. Yep, so ArcGIS API for Python is different than, repeat that. ArcPy, thank you. And yes, simply because the branch version feature services require that you utilize that in the Python scripts. Oh, did I not? So the question was, why use ArcGIS API for Python over ArcPy? Yes.
I have two quick questions. I realize every utility is going to be different in size, but you've already told us about the size of yours. So what was the approximate time frame for these different phases? Like you're cleaning up your data, you're doing your review of the data model, and then all this different stuff. Can you give me an idea
Yeah.
of what the time frame was?
So the question was, what was the time frame for the two different phases we had? The phase one, which was just coming up with a plan, setting up our IT architecture and data quality review, looking at our data before we migrate. That was about 6 months. And then phase two, which was the actual migration process, there was a gap in between phase one and phase two, which allowed me to do a little bit of the data cleanup. And then we started with the next fiscal year, basically. And then on phase two, that was about 18 months.
Second question, you mentioned that as you're getting ready to go to production, you have to freeze editing. Does that include city work orders as well?
I'm not sure, to be honest with you. I don't think so, because the asset, yeah.
Yeah, I would think you can still continue.
I think you can still continue to
make work orders.
attach assets to a work order because the information, the asset ID and all that doesn't change, but I'm not positive on that.
Yeah, as
it's a good
long as
question.
your asset IDs are staying the same. Because we do have cases where, IDs are changing, formats or something. So in that case, you want to make sure to take that into account during the CityWorks reconfiguration process. Yeah. All right, good.
Yeah, you got 1 minute left.
All right, any other questions? We got time for one more. All right, thank you, everyone. Appreciate your time.